Ladies and gentlemen, it is 3 p.m. 3 p.m. in Noordwijk in the Netherlands. It is still very snowy around here, and we are today talking about 3D printing with Francesca Lolio from Ferrari in the room. Ferrari is in the room. Let's get started today. 3D printing of metal. Last October, we had one of the most spectacular online meetings to date. We examined laser metal processing, bringing together the entire supply chain, including large corporate users like Siemens and Audi. We have since then been very busy talking to new users, including Avio Aero, GE Additive, BMW, NASA, as well as Rolls-Royce. But while discussing this expanding field of metal additive manufacturing, we uncover several important unmet needs, which means there's plenty that needs to follow up. So on Wednesday, February 10th, we'll organize a reunion to bring back those leaders in their field. We'll also introduce emerging players who are exploring new paths with new challenges for the supply chain. As you may recall, Siemens was very interested in high-speed monitoring systems. Let's involve the N-Word cameras from Xenix or new imaging technologies, because EPIC members really excel in this kind of expertise. Our Zoom room experts from Additive Industries said that for them, the big challenge was on machine vision for real-time metrology of 3D printed structures. Yes, yes, yes! Machine vision is a very popular EPIC topic. Let's match the companies who can measure any 3D printed feature in real time with ultra-high resolution. Since so far, LambdaX or Opto immediately come to mind. The 3D printed metal service provider BIMIT wants to co-develop near-infrared laser processes for materials with high refractive index. So let's see what system integrators like Lasea or Prima Additive have to say. And I can't forget the amazing presentation from Laserline and their challenges with laser optics for 20 kilowatt CW operation. Laser optics? They could not have knocked on a better door. Aspericon, Optoman, WCW, Altecna, everyone's here and ready to do business. If you want to share insights, then sign up now for access to the Zoom room or watch live on YouTube on Wednesday, February 10th at precisely 3 p.m. Yes, it's time to 3D print the world with metal. As you can see, I'm having so much fun preparing these videos, and then I also love the energy that they try to bring to this community. We are doing so much work on trying to bring the integrative photonic community together, the laser community together, the medical industry together, and Francesca Moglia from EPIC has done so much work in the last weeks, connecting all the different companies that we have in the 3D printing of metal sector. I actually have some news. We are really close to having to change the logo over here. We are 683 members. Actually, a few minutes ago, we got the membership forum from Stensborg. Thank you very much for the amazing support that the industry, the photonic industry, is giving to EPIC during these COVID-19 times. Thank you so much. I cannot thank you enough. Also, on behalf of a fantastic team, 15 people, half of them with PhDs, we organize events, we give access to investment, to jobs, and we provide the market reports. And most important, we love photonics, and we try to make sure we understand the technology of every member of EPIC. Today we are talking about 3D printing. We are already in the mid-season, and if you are interested in any of the upcoming topics in March, please register as soon as possible so we can understand which companies we should bring to make sure that you do business at the meeting. Pay special attention to 15th of March, LiDAR 2.1. It's going to be a spectacular meeting already. Great companies have signed up. And also for the first time in 2021, EPIC is also supporting the quantum photonics industry. We start on Friday with quantum computing. If you have interest in quantum, if you think your technology could be suitable to quantum applications, or you simply don't know what's going on and you want to find out what this is all about, why there is so much money going to quantum technologies, do not miss any of our upcoming online quantum technology meetings. But today is 3D printing of metal, and I would like first of all to acknowledge the support of our fantastic media partners, PhotonicsVies and AZO Materials. Thank you very much for all the amazing support that you continue giving us. And this meeting wouldn't be possible without the support of our amazing sponsor today from the amazing city of Jena, Jenoptik. Jenoptik is providing highly sophisticated FT lenses and beam expanders, and he's here talking to all the different 3D printing machines to make sure that they brought their different technology portfolios of 3D printing. Let's work with Jenoptik today. Jenoptik, thank you very much for sponsoring this meeting and for being that amazing EPIC member. Today we have an amazing agenda thanks to Francesca. Francesca, you are the only person worthy of explaining what's going to happen today.
Thank you very much, Jose. Thanks a lot, everybody, for being here today, also on YouTube. And as we usually say, we are here the list, a bit a boring one of 6 speakers, but that is not what this meeting about. The meeting is about this better, much better slide. So this is representing all the people who sign up for today and actually is filling up our value chain for the metal 3D printing. As you see, we have end users from 3 sectors that are happily interacting with us all day to say and explain their challenges. We have 3D printing equipment and services. Some of you sell the machines, some of you only the services, some of you both. So it's really interesting to have this also middle step of services and job shops. Then, of course, we have all the full rest of supply chain that is really interesting because we have, of course, the laser manufacturing, packaging, the cameras for monitoring the processes and the processing system, beam shaping, all possible is here. And I guess the best way to let you giving the floor is to accelerate this introduction and go back to Jose and to you.
Francesca, you've done such an amazing job. Such an amazing job over the last months, connecting the entire supply chain of all the different advanced manufacturing technologies. Hats off to you. This is frankly amazing, but this slide only corresponds to the companies who registered for the meeting today. So if you are an EPIC member, you're missing your logo in this slide. This only means that you didn't register for this meeting and there's nothing I can do about it. Please, if you have interest in any of the upcoming meetings, register so we can position you in the supply chain in the place that you so well deserve. And this meeting is, of course, also broadcasted live in YouTube. So hello, YouTubers. If you want to get in touch with any of the participants today, all you have to do is send me an email, jose.pozo@epic-asoc.com, and I'll make sure I make the introduction and also use the chat to post any questions you may have, and I will read it in the room. This is also valid for the people in the Zoom room. If you want to get in touch with any of the participants, use the internal private chat and have internal private conversation. This is how you do business. But if after the meeting you didn't get a chance to talk to the person you wanted to talk to, send me an email and I will make sure I do the introduction and we do business. And that's it for getting the meeting started. Let's go to our first speaker today. Francesca Moglia prepared the agenda. I want her to have the honor of introducing the first speaker. How do we start with today, Francesca?
Thanks a lot, Jose. So he should be in the room. And he's from Equinor, is Brede, right?
Yes, that's right.
Yeah, there you are. Thanks a lot. Thanks a lot for joining us today. We start with an end user, so in an energy sector. So we are really looking forward to listen what you have reserved for us. The floor is yours.
Thank you. I'll just share my screen.
Yes,
just give me a second.
Please. We are in business.
Excellent. So thank you very much for inviting me. My name is Brede Lærum. I am head of the 3D printing strategy and implementation in Equinor. I need to say a few words about Equinor. Sorry, going back. Equinor used to be called Statoil. Now we call Equinor. We used to be known as an oil and gas company. Now we are a broad energy company. We have 3 main focus areas: always safe, high value, and low carbon. And what I find very interesting is that additive manufacturing actually answers to all these 3 main focus areas. We have a quite ambitious digital roadmap, and you see that to the right of the slide here. 6 different program areas. We have a data platform in the middle and several different digital technologies that we are working on. So let's just move on to the additive manufacturing. But actually, I'm not going to talk about additive manufacturing alone. I just want to say that we have looked into machines, materials technology, all the technology for a long time. What is possible with additive manufacturing? But you're now moving into a new phase, how can we make business out of additive manufacturing? And what I would like to really spend time on is the digital inventory. And in Equinor, we've started a project together with two companies, FieldMade and Siemens Energy, with support from Innovation Norway, to build this new data platform that holds this new digital supply network. You see that diagram in the middle. And the digital inventory uses additive manufacturing as a catalyst, because additive manufacturing can give us fast, reliable production of parts on demand. And that is the whole main idea about the digital inventory. We can store all the digital parts available in the market. That means all the different suppliers will have their own parts in their own control room, and that they can share this into the digital inventory. And me, as the end user, I can find a digital model, order a production of the part when I have the need. Of course, I have huge physical inventories already. And it has cost me a lot of money, or Equinor a lot of money, to build up these huge physical inventories. And between 80 and 85% of that physical inventory will never be used. So for me, it's a complete waste, but it's an insurance policy in case I need it. So I tend to call, we now move from just in case to just in time. So we want to produce the parts on demand, just in time, when the need arises. And with this digital supply network, this is possible. So we're moving from the left, from a linear supply chain to a digital supply network using additive manufacturing. And you have all the different kind of suppliers in this network. We have us as the end user, of course. You have the producer, the just-in-time factory. You have the OEM, the ones who own the IP rights. You might have engineering companies. You have the verifiers doing the certification, and you have, of course, logistics. This means that in the future, when this is installed and ready by spring 2022, we will start purchasing digital parts from anywhere in the world, and then we can produce it where it's most suitable. So that means if we need a part for one of our offshore fields in Norway, we would like to produce a part in Norway. If we need a part for one of our plants in Brazil, we would like to produce a part in Brazil. So that means you're independent of geographics, but still you have the local content. And this gives us a lot of benefits. And this is a brief introduction into the benefits of what we see. First of all, we can increase revenue. We can reduce the physical inventory. I've already talked about that. We could also reduce maintenance costs quite dramatically. We can reduce modification costs, production losses, and we can improve performance. I guess all of you know how this can be for real. But especially when it comes to reducing maintenance and modification, that means for me, instead of replacing a whole compressor, a whole pump, because we have one component inside that is faulty, we can now 3D print the one part that is the problem, and we could replace the single component instead of replacing the whole system. So we are in this also changing our maintenance philosophy. The next one, which is delivery assurance, I think this is very important. We can use additive manufacturing and this digital inventory to start home sourcing production of physical components from low-cost countries and back to Europe, back to Norway, back to Italy, back to any country in question. That means we want to focus more on local production and services rather than import, because we can use additive manufacturing, a highly automated manufacturing method, to produce those components locally. We know we can reduce lead time, we can reduce the need for crossing borders, and we have seen during the COVID-19 period now, factories close down, borders close down, we can have problems with our supply chain. But having this distributed model, we will see a much easier access to the parts that we need. And we need to involve the whole supplier industry, because we want to produce the parts where it's most suitable. When it comes to environmental footprint, I think that's very important as well. When we can reduce transport, of course, we reduce CO2 emissions, but also by reducing raw material consumption. That is also a very important factor when it comes to the environmental side. We see that 30% of the energy consumption in the world comes from extracting raw material. And using additive manufacturing, we can reduce the raw material consumption, and therefore we can reduce the energy and CO2 emissions. We can reduce the replacement project. So instead of discarding old components, we can repair them, extend lifetime, and therefore reduce our consumption of spare parts. So additive manufacturing, as we see it, is perfectly fit for a circular economy. It's just one thing, and that is we have a huge job to do. We need to develop new business models. We have to develop this new way of working around the digital inventory. And of course, additive manufacturing is perfectly fit into this new model. So that was my message for today. Thank you very much.
Thanks a lot, Brede. Wow, that's something that we really support, because if you present such a nice way already of supporting you and how you're already interacting with your full supply chain, it's basically what we always support also and do with Photonics. So my question would be now, where do you see the connection and participation from the supply chain from Photonics, like more starting from the machine builder also, but the Photonics yourself, and where do you see the challenges that the supply chain could help you with in of course, implementing this system?
Okay, of course, there are many answers here, but one important issue is that it's not efficient if every supplier and every end user should start building competence and capacity in additive manufacturing and start purchasing lots of machines and having their own production capacity. That's not efficient. So if we can imagine, if we go back to my previous slide, having factories distributed geographically around Europe, we need maybe joint ventures between suppliers to go together and build these factories. You need, of course, to build competence. You need different kind of production methods like additive manufacturing. You need CNC machining, you need heat treatment, and you need, of course, maybe both X-ray and CT scanning to ensure quality. So building these centers so that we can get the production capacity we need for the future. So these will, I call them just-in-time factories, or you can call it on-demand production, call it what you want. But to start working together and build this as an industry rather than working independently, everyone doing things on their own, I think that can really help us going forward.
Can I also ask you maybe if you see that it could be a challenge if we don't do like this, that subtractive manufacturing will be always winning against additive manufacturing? Is it something that maybe can be an obstacle for additive manufacturing?
Definitely. I meet a lot of resistance within my own company. I see also a lot of suppliers who are resisting this change. And of course, change is difficult. You have to move into the unknown. You have to maybe do some things that are killing your old business model in some respect. So it's quite hard. And that means we have to make sure that we show concrete examples of the business benefits of this, as I've already shown you, and therefore start building down the resistance towards this quite dramatic change. I call it a total transformation of the way of working here.
Great, thanks a lot. That's really nice to hear a supporter also from the end user side of additive manufacturing. So let's see now what the supply chain says. So we have Harry from additive manufacturing that would like to make a comment, right, Harry?
Yeah. Hello, everybody. Harry Klein from Additive Industries. I think your presentation really connects also to what we envision. We are, of course, a system supplier for 3D metal printing systems. But we realized that to set up this, say, distributed supply chain with all the quality constraints and of course certification specifically in the oil in the energy market, is something we have to, as an industry, to work together on. And I think what we see already is quite some progress. We are working together in a joint industry project together with DNVGL, also supported by Equinor, where we are now making a framework. What would it mean to make such a, what would it take to create such a ecosystem in an let's say in a practical way, because it is for us, for example, as a system manufacturer, we need to know what kind of requirements are needed do we need to fulfill to nurture this supply chain in such a way that let's say the end producers of parts can produce these parts in a controlled and predictable way. So yeah, there's still I think the vision is fully supported. Still a lot of work to do, but I think with the joint forces and all the companies we're working on this, I think this will be realized in a few in a foreseeable amount of time, and I think somewhere between 2 to 3 years it should be live.
Thanks a lot. So we see there is alignment, let's say, also from one part, at least the machine builders are in. So what does the supply chain then say? So the laser manufacturers, for example, the optics manufacturers, the scanner manufacturers. So what is your opinion in this? Maybe Michael from IPG Photonics has an opinion, right?
Yes, hello. So let me ask whether this distributed facilities and building the ecosystem is the only issue, and you're not looking into build rates, repeatability and quality of the products anymore. This is my big question as a supplier of the laser source.
Okay, maybe I can try to answer. Of course, the question you raise here are extremely important. Quality. We have the same strict quality requirements as we have for traditional manufacturing. We just have to prove it in new ways, because this is a new way of producing parts. So, but the thing is that we have a lot of focus on ensuring quality. The JIP was mentioned together with DNVGL. I know that TÜV and Lloyds, they also have quite good routines on how to certify factories, certify ready parts from additive manufacturing. So that is going its course. So I think that is being dealt with in a sound and good way. I know also that API has just started issuing their requirements for additive manufacturing metal parts. So, and also ISO and so on, they're all working with the requirements. So that is ongoing. But I haven't seen really a good effort on the ecosystem methodology, and that's why I'm raising this as a new topic that we need to look into to move into the future and put all these different bits in the puzzle into a whole picture, so that we can have business in this and not just running around trying to convince the world what is possible.
I love that you're here. I love that you're here as an end user telling, this is the real end user presentation. The one is like saying, these are my challenges. In the comments, Harry said standardization is key. Standardization is key. I am the least supporter of standards in the world. I really don't like standards because I love innovation, and standards are always a problem for that. But standards only happen if we work together. So what I want to do here is to really understand how we can do something that is suitable for the end users. And when we talk about additive manufacturing, the first thing I think about is materials. It's about saving materials. It's about minimizing the waste. Is there any slogan, any message, any ideas that Equinor is putting there towards minimizing the waste in production?
Is that a question to me?
To you, of course, my end user.
Yes, yes. We see the environmental side is very important, reducing raw material consumption, and of course, building additively gives us a better result than subtractively. So, of course, the answer is quite obvious. But we want to put it into a new context. And we believe that even though we want suppliers to work together, as you are in this EPIC association, but still you can specialize. So instead of being a supplier that is both developing design and doing the production and doing the whole line of producing a part, you can specialize in the digital design, and you can produce a part at the factory that is more suitable for you. And then you can also specialize in producing mechanical parts with additive manufacturing, CNC machining, any method that has high quality and high speed and is highly automated based on a 3D model. So as you see in the diagram I had in the middle, you can also specialize in those main roles that you see in the digital supply network model. So I think that's the other message I see. You can go broad or you can go narrow and specialize in one area.
Okay, we are going to come to you because you're going to collect other end user views later from different top companies that we have in the room, and we're going to have a little bit of a debate. I can tell you that the spirit here has to be that we all have to know exactly how to work together, and in 2 hours this is going to happen. And now we go to another end user. We want to now print instruments, print valves for hydraulics, and they want to use 3D printing. This is a company in Italy represented by the president and CEO, Valeria Tirelli. AIDRO Hydraulics. Thank you very much, Valeria, for being with us this afternoon. Grazie mille for being here. The floor and the attention of everyone goes to AIDRO Hydraulics, goes to you, Valeria.
Hello, everybody. Thank you very much. I'm very happy to be here.
Not as happy as I am for having you here. Let's see, can we share your screen to see the bottom of the Zoom window?
I think, yes, please. You can share my presentation.
Yes.
I do it.
Yes, thank you.
Wait a second.
Yes.
Valeria, where is AIDRO in Italy? In which part?
Yes, we are in the north part of Italy, not far from Milan, but in the countryside, so very close to the lake, surrounded by mountain Alps. So I can tell you also that nature inspired us to be involved in additive manufacturing.
I am going to come to visit you as soon as we can travel again.
Yes, you're welcome. So the company was founded by my father almost 40 years ago. And as you already say, we work in valve and hydraulics components. This is a quite conservative sector. And we work with conventional machining, casting, and all the traditional manufacturing methods.
We can already see your slides, I believe. Francesca, press F11 to make it a bit bigger. And
it's Helena.
And let's hear about AIDRO Hydraulics and 3D printing.
Yes.
I'm super excited about this.
Yeah, you can see on your left the conventional hydraulic manifolds, so made by machining, casting, very conventional shape, but with good function, of course, because hydraulics components are used in many different applications from industry, like industrial machinery, but also mobile, like automotive, agricultural machinery, oil and gas plants. So there are a lot of sectors using hydraulics. But as I said, the same valve, same manifold are made for at least 70 or 40 years at the same time. A few years ago, we discovered additive manufacturing. At the beginning, it was only for making prototypes or tooling for our conventional production, but we understood that there are a lot of benefits that we can have with this technology. So we start to make new prototypes. At the beginning, it was only polymers, but then we discovered also metal parts. And we start to create a new generation of we discovered a new generation of metal parts. We started making, designing and engineering parts with a new approach. We changed our mentality. We also had to train our engineers and technical people to understand the benefit of these technologies. And we started to look at the problems in a different way with a new approach. We were able also to develop new products thanks to additive manufacturing, thanks to the fact that we have a fast prototype. We tested different shapes, different function, and we are able to create a new serial production in a very short time. But we discovered also that with additive manufacturing, we can integrate more function into one parts, or we can combine multiple components into one, so saving assembling time, for example. And also we understood that there are a lot of benefits in the digital transformation. So to start this new journey, also together with other companies, not all alone, but to start to think that in the future, we will change our, for example, spare parts from physical spare parts into digital spare parts. This is an amazing plan. But we have to start today to understand what is additive manufacturing. And we decided to invest in this technology and make our internal department with a laser machine powered by the fusion. So we have some printers in-house with different materials, and we learn day by day. So making parts, designing parts, and then printing parts, we learned a lot. And now I think we are ready to do something for other companies, but also to learn and collaborate with other companies. And in the next slide, you can see that we can do different products, but the idea is to share the challenges, to understand which are the actual problems, which are the, I can say, problem that seems impossible to solve. And maybe we can say with additive manufacturing, with a new approach to the situation, we can find a new solution. The idea is to also create parts, innovative parts, smart parts, for example, including sensor. You can see on your left, this is a heat exchanger with an innovative shapes, and it will be integrated with sensor. So to take into account some measurement like temperature or pressure. But the idea is also to have a big and new generation of product. But to do this, we also need a better and faster printer. So this means with more laser. We have, for example, one laser, two laser machine. Now we have 12 laser machines that are developed by some manufacturer. But I'd like also to ask to photonic industry, maybe you can think to have 1 million laser machine to have a faster production and to help additive manufacturing to become the really mass production for the future. So I'm really happy to be here and maybe
Thank you so much, Valeria. No, don't worry. That's going to happen. We're going to find collaborations. There are many questions. This is an epic meeting and you knew your lesson. You came here with challenges. The first question comes from Michael Lee from IPG. Michael, what's on your mind?
Yes, on my mind is, as we have the end users in the room, and we know, or we have seen it from the well-developed semiconductor industry, that they lay out a roadmap for us, for this photonic supply chain, in terms of what are their future tasks in 1, 2, 3 years on build rate, costs, and so on. As you mentioned, you increasing the number of lasers. Is that all what you would solve? The challenges? What challenges you have today?
Yes, today challenges with the machine are, say, multiple challenges. The productivities, of course, is one, and maybe could be solved with laser. But also, I can tell you the cost of the machine, because today there is a different manufacturer of the machine, but the average price is quite the same, and it's still a quite expensive technology. So to implement this technology, at the moment, we had to find a good balance between the added value of the product and the cost on the market. So another good point could be to reduce the cost of the machine and the cost of the products.
We have another question in the room. This one is coming from Manoj Pillai from Jumbo 3D. Manoj, what's on your mind?
Hi, Valeria.
Hi.
Good to finally see you in a presentation. I've been following you in, in LinkedIn. Yeah, LinkedIn for long. I'm right now in Dubai. I work for Jumbo, and there are a lot of oil and gas companies in India, in Dubai and UAE. So I have seen your many designs of manifolds which have a lot of applications in this region. And I would like to know how we can collaborate rather than reinventing and doing the entire thing over here. I've been, I have done taken inspiration from your posts in LinkedIn. I have done some designs while I was working for another company in India, but I don't want to do the entire exercise here. So is there any way we can collaborate and see you can be our manufacturing partner and we be your supplier over here?
Yes, as you say, there are many different type of collaboration in the additive manufacturing industries. We can start to redesign the manifolds. For example, we take a lot of benefit in the redesigning, make it lighter, reduce the size, make better function, so better flow inside the channels. So we have a lot of benefit in 3D printed manifolds, but also we can also think to make the engineering, for example, in Italy, the printing, maybe the first prototype we can print in Italy, but in the future we can also think to print locally, for example, with the same file and with the same printers. For example, based in Dubai or in India, we can just send the file that is already validated in AIDRO, but you can print locally. So this is one of the big benefits of the future. So to save transport cost, energy cost, and to have a very digital, distributed manufacturing process.
Valeria,
yeah, sure.
Thank you so much, Manoj, for being here. Valeria, for the next question, I want to make something special. We welcome today one of the most important companies in the world industry and one of my favorite companies in the world. We welcome Ferrari. Francesca, thank you so much for being with us this afternoon. What's on your mind?
Thank you very much. I'm very happy to be here. And I would like to link to the question from my colleague and to the answer from Valeria, because we are in the same, not the same, but similar situation. So we produce prototypes and we are looking for the future, maybe for the series production, but we are far right now. I would like to say the same as Valeria, and also to add that okay, today parts produced by additive is quite expensive, also machines and so on. So to make serious production is difficult right now. And also, in my opinion, the post-process is difficult to sustain for a serious production. So support removal and so on. So for me, if we want to follow in the future the line, and I will be very happy of additive manufacturing, in my opinion, it is necessary to review the post-process, or maybe the additive manufacturing in the optic of post-process. So maybe less supports, or not to use supports and so on. So thank you very much.
The post-processing has been always a challenge for us. Post-processing and real-time inspection come hand in hand. It all depends on the materials that we always target. Stainless steel is very, very different than copper. So what we want to understand a little bit is, if you could share, I know that we want to have many, many different meetings with you in private locations, but if you could share with us maybe a few materials that are in your mind right now for this group of companies to work with.
Yes, of course, we use only aluminum alloy. So we are talking about only aluminum. Here in Ferrari, we use also other materials, but maybe for F1, okay. But for production of cars, we use only aluminum right now. So I'm talking about aluminum for this moment.
At some point, when we had the 3D printing of aluminum, you talk about post-processing, the application of coatings, also real-time, reliable-wise, is also a room for cooperation. Could you share with us, maybe, I know we had to have a lot of secret meetings after this. I'm almost crying, Francesca. We have to have a lot of secret meetings after this, but is there any particular challenge, like aquaphobic or easy to clean, or any particular dream that you have for the post-processing or the coating treatment after the part is printed?
Well, not coating, because we are not working on this, but maybe I repeat myself, but the production in a more sustainable way. So not to remove manual supports after 3D printing, and I mean for prototypes maybe. So not to study a process for one piece in series, but to remove supports in an easier way, but for prototypes, so different components every job and every time. And for me, this is one of the key factors for the future production, in my opinion.
Francesca, welcome to the EPIC community. Francesca, Valeria, I have more questions from the end user side. I'm going to continue with the questions. The next one comes from Kylabs, one of my favorite companies in beam shaping. Tiffany, thank you so much for being here. What's on your mind?
Yes, hello everybody. We also like very much this EPIC meetings. We find it great. And thank you for letting me asking this question. We are making beam shaping system, and I'm wondering if in your several process of 3D printing, did you already try some beam shaping to increase speed and quality process, so that could lead to diminution of post-processing?
It's a good question. Of course, as already said, the post-processing is something that can be very crazy activities. So what we do now is to concentrate our efforts in the design. So to have the best design to avoid the post-processing, or better, to make the design thinking about the post-processing. So to have the best possible reduction of the post-processing, like support removal, or possible, powder blocked in some strange area that are not accessible, and so on. But as already said by Francesca, I'm convinced that all the industry have to work a lot to make some improvement in the post-processing. So I have no direct experience, but I'm really open to test it or to share experience if you have it.
Valeria, one more question for you. This one is coming from Harry from Additive Industries. Harry, what's on your mind?
So I think addressing both the remark of Valeria about the cost as well about beam shaping, say from industry perspective, this is one of the key topics we are working today on. Actually changing this, adopting this build speed of beam shape to further speed up the process in one way, so you can have a higher deposition rate, and on the other way, it is to avoid any support structure. So that means that in due time, it's a matter of time, it's a matter of development. There will be, let's say, we call recipes or processing sets come available, which will at least reduce the amount of supports needed and substantially improve the productivity. And this is also a teaming up of the whole industry, because we buy, of course, we have our optic sets as an equipment manufacturer. We have to work together with our optic supplier to see what's possible with the laser supplier. So in this way, innovation there is really coming in, is really kicking in. On the other hand, of course, once you have chosen for a specific concept, then finally you freeze your technology. Then you have to wait for a little time before you can move forward. But already, what I can say with the concept we use in our machine, we already improved productivity by 20 to 40% just by having different beam shapes. And in the future, for example, we also during the Formnext, we launched a case where we produced with 4 lasers 1.2 kilo of Inconel per hour, which is really a great achievement. 150 kilos printed in 5 days with this specific new, let's say, beam shaping settings, as well as the recipe behind it. So yes, we see this challenge of the cost down, and that's actually where we as a system vendor are working continuously on, but also, of course, in very close collaboration with either our customers as well with the optic supply chain.
Harry, after the previous meeting, you put some challenges up there, and I made a lot of introductions for you, and people told me that it was really nice talking to you. So thank you so much for following up with all the different introductions. And any company that wants to get in touch with Additive Industries, contact me. I will introduce you to Harry. He's really great. Thank you, well, Harry. Thank you so much for this. But I also have one more question in the room. This one is coming from Torsten from AMS Technologies, all the way from beautiful Boncenne. Torsten, what's on your mind? The sentence of EPIC 2020 is, you are muted.
Yeah, that's it. Okay, so I'm unmuted now. The question maybe goes also to Harry. So we are working on high-speed electro-optic scanners together with some partners in Japan. So I'm wondering if this would help to increase speed. Of course, you need some treatment time with the powder. So I'm not sure how, if this would be something which is worth to discuss.
Definitely, of course, the speed of the laser speed and high speed, and especially really going in depth, there is a lot of let's say overhead in guiding a laser, and the more you can eliminate that kind of overhead, the faster we can run the process. So that's that's I will check with our Let's Team Up after the meeting, and I get you connected with our optics guys.
Okay, great.
Let's continue this innovation meeting. Before we go to the next speaker, there's something big happening in EPIC these days. We're actually doing a lot of new product launches. And in the previous product launch, we had a presentation from a new product by Enlight, actually put in the market by Optoprim. And I think it really fits here, Christian, if you refresh our mind, there's a huge room for cooperation. Christian, what do you have in mind?
Thank you, Jose, for giving me the possibility to
beautiful background, love it.
Introduce you to a new technology. We heard it today quite a lot. It was about beam shaping and how to improve productivity. And I can show you something. We have something in combination already working. I hope you can see. It's a fiber laser with beam shaping possibilities from single mode to ring mode beam shapes. It's good for precision, for lattice structures, perfect for mixed geometries, and especially if you want to have bulky parts with high performance parameters, you can use ring mode. You can enter much higher power within the powder. And we have seen even factors of 3, 6, for some materials, even higher in productivity by keeping the same porosity and quality of the part. And we think that can improve really the AM process, make machines more, profitable in terms of cost by parts will go down. And maybe that's the next step or level for the AM market and production using parts in the industry.
Christian, what's really, really amazing here is you can go from one shape to another while keeping the average power. And we are talking about high range power. We're talking 500 watts, more or less. We're talking high range power, keeping the average power in milliseconds, going from one shape to another. This is truly amazing.
That's correct. That's correct. So we have really the 550 watts are in the core, but the total laser power has 1.2 kilowatts. So, and we can distribute the power from the inner side to the outer side on the fly. So during the scan speeds, within the different, let's say, geometries of the part, inner, outer, fine features, mixed features, and so on. So that makes it really strong, flexible, and basically very productive at the end.
Christian, good luck with the Prism Awards. I'm betting on this one. Good luck. But I want to go to Michael Lee again from IPG Photonics before we close this first part with the end users. Michael has a very interesting thought to share. Michael, what's on your mind?
Thank you, Jose. So again, I'm on the costs, and we just have seen there are some beam shaping or fishing ways of doing beam shaping, which can reduce the cost and increase the productivity. Years ago, I heard about this factor of 10, which was required to reduce on the AM side to be more competitive and one-to-one heading with the subtractive technologies. How do you see, to the end users and integrators, how do you see this factor today?
Let's go to Valeria first. Valeria, yes. How do you see it?
Yes, I think it's really important to increase the productivities of the machine, so have more laser. But of course, it takes other risks, for example, concerning the certification point of view. If we have more laser, the certification will take more time, more testing, more specimen. So it can be interesting, but also more complex. So we have to find the good balance between the productivity and the complexity.
I want to go to Brede now from Equinor. Brede, when it comes to the roadmap towards the cost reduction, do you have some comments, some ideas, some Santa Claus Christmas list? Brede.
I think you've been into some very important areas. As you said, we look into cost in a holistic version, but also cost and time of the actual production is key as well. We've seen so far that 3D printing, additive manufacturing can be much, much faster than traditional manufacturing, but increasing the speed even further is important for large parts. Of course, in the oil and gas industry, we have valves in tons. And of course, if we would like to succeed with the digital inventory, size matters, speed matters, and of course, quality matters. So we still have a lot of work to do, but still I see that we've come so far that we can still put it into a business context and start building this digital inventory. But keep working on improving the operability, the functionality, and the speed and everything. I think we will see some very interesting results as we move along.
Thank you so much, Brede. Francesca from Ferrari, I don't expect you to comment on this. I don't want you to comment on this, but you know what I want? Pay a lot of attention to the next presentation, because Precitec is one of my most beloved companies in EPIC. It's going to talk about something very interesting for you. Laser metal deposition combined with 3D printing. You're going to love this. The next speaker is my friend Markus Kogel-Hollacher from Precitec, EPIC member Precitec. Thank you so much, Danke, for being here. The floor and the attention of everyone in the EPIC community goes to EPIC member Precitec. The floor is yours.
Yes, thank you for the kind introduction, and hello everybody for this interesting afternoon. Again, an interesting topic EPIC put together. Yes, I think I can answer some questions of which have been asked in the last hour. And I want to put your attention on the fact that 3D printing is not only the how it's now named PBFLB process. So it's not only photonics or photons and powder bed. 3D printing is more. So just to give you some information about Precitec, you should go to our website. So I don't waste any time on that. So if we talk about printing, we also talk about DED with powder. So these are the typical nozzles you find in DED processes: off-axis, ring nozzles, multi-beam nozzles. So this is not new, and this is not no innovation behind. But if we talk about innovative machines, we need to talk about beam, for example. The beam is using our devices, our modules. Precitec is famous about generating modules. It's like Lego. For laser technology, to just put together the beam guiding modules you need for your machine, and Beam is using our modules for their machines. And as you see, they can print amazing parts. If you talk about big parts, they can print amazing big parts. This looks like wood, but it's titanium. So you see the construction time, you see the weight of the part, and everybody who knows printing titanium needs a shielding chamber. This is special about beam machines. They are experts in shielding the chambers. But one of the topics Jose was addressing in the invitation is sensor technology. It's sensors, machine control, machine vision. And as you may know, I'm talking about one sensor for the last decade, which is the OCT sensor, which from my perspective and from the perspective of many users nowadays is the only sensor in photonics which can really measure the needed information during processing. And the needed information in 3D printing, in additive manufacturing, is surface height and surface structure, surface topography. And this is what we did together with Siemens in one of the projects of the European funded project we are involved, or we have been involved. This project is now finished, and we were able to build closed loop control for DED powder processes based on OCT. So we do not control laser power. We control the speed. That's why we went together with Siemens into that project. Because if you take a deeper look into the control variables, you will see that speed is much more effective on process regulation than laser power. I don't want to go into deep detail. That you see that this is the uncontrolled process. We have a controlled process later on, but so this is the closed loop control we use OCT with. But let's go to my other favorite topic, which I'm talking about for some years as well. It's the GPS system for photons, which I call the future of laser materials processing. We have talked about that in the question and answers on the last presentation. So it's important to know where photons should do their work. And it's important to guide the photons to the right position. Fiber powder bed or not powder bed. And or in subtractive photonic applications with ultra-short pulse lasers, whatever. We are talking nowadays on GPS systems for photons. And one of the devices we have generated in the past is our printer head, which we called coax printer. So if you do 3D printing, and if you use the wire as additive material, the easiest way to be direction independent is to support the wire from the center and to bring the laser from the side. And this is what we have realized with that optics, with that processing net. You see that we come from a standard laser. It can be any kind of laser, any kind of beam quality, which we can use. So we generated a ring, we open the ring, introduce the fiber, close the ring, and then we do the printing. And what is important, so you see one of the devices we have recently installed on a machine. You see also all the interfaces for the state-of-the-art sensor technology, camera, OCT, pyrometer, everything can be adapted. It's again the modular principle. And if you compare that process, which is here in the middle of the table, with the completing processes on the left, you see the powder process. On the right, you see the wire process without photons, what we call the electron, not electron beam, wire arc possibilities. You see that we are very good in accuracy. We are very good in filling rate. Filling rate here is getting even better. I will talk about that later on. And so this is a very, very interesting alternative to 3D printing from the powder bed. What makes that optical principle so unique is that with the special beam, we heat up the wire before it's going into the material or on the surface, so the process is very smooth. It's even the smoothest process you have ever seen in laser materials processing. But this is the topic. We can use any kind of material. So you see we did processing with stainless steel, with aluminum, with titanium, Inconel, flux core wire, bronze. This is easy. You change the wire in less than 2 minutes and you're ready to build another part with another material. And here you see some application examples. You see always a battery here or a telephone, a mobile phone as example how big we are. Here you see the other applications. And what is very important, as I said, the process is the smoothest photonic process you have ever seen. And we don't waste any material. 100% material use. You do not need to clean anything. You do not need to recycle anything. This is the future of 3D printing. And so let's take your messages to take home. If we talk about machine vision, OCT sensor is the only measuring device in DED. It's also a measuring device in powder bed, the PBF-LB process. I haven't had the time to go on that topic. We show application-specific intensity distribution with the coax printer, and we show that this is a high flexible process. Okay, so what can we do for you, and what do we need from you? So we offer the most easiest to handle 3D printer device for build-up of near net-shaped geometries and functional assemblies. This is no question. What we need is to raise the confidence that the DED wire process is a real alternative for 3D printing. And we did show that there is more potential applications, for example, hybrid application. So already existing products, you can print on your functional device, and then you can generate standard parts by subtractive processes, and take the hybrid, the 3D printer, and print on this part you need there. Okay, so thank you very much for your kind attention.
Thank you very much, Markus. Thank you so much for this. And thank you for all the different opportunities that we have here. Francesca is smiling. When Francesca smiles, I keep quiet. Francesca. You are muted. We can't hear your beautiful voice. I don't know what's going on, but let me take this. Markus, this is an epic meeting. You know, epic, and thank you so much for joining. You made me so happy. But in the epic meetings, we ask the epic question. So a few specific challenges, room for cooperation. What can you do for them, and what can they do for you?
Yes, so as I said, so if you think about 3D printing, you should not always think about the powder bed machines. So we have heard powder bed machines are maybe too expensive, maybe too slow. There is a difference between powder bed processes and what I have shown. It's the accuracy of the structures you can generate. But if you do not have high demands on very fine structures, you can easily take a processing head, which I have shown, put it on a robot, and print your part. So you just take the CAD data file, put it into the path planning, and at the end you're ready. It's near net shape. The surface quality is excellent. It's comparable to the PBF-LB process. So this is actually, and as I said, we can use any kind of material. So every wire you can find on the market can be processed with photons.
Francesca, can we hear you? 1, 2, 3. Oh, I think we have a problem with Francesca's cell phone that we're going to solve in the meantime, but I want to now start some room for cooperation with Precitec. The first people that they have something to comment here is, again, Christian from Optoprim. Christian, what's on your mind? You know, Markus, when you make this meeting live, this happens, and it's super awesome because I'm fully in control here. So,
I know.
Yes, Christian, what's on your mind?
I was not raising the hand, but let's say in general, this was an interesting presentation. I think in general, and also let's say not only the powder bed is for sure one interesting process. Also, the wire DED is very interesting from Precitec we have seen. So also for that kind, yeah, the right laser technology is always used, and the flexibility for sure is also quite nice. And yeah, we always support also Precitec with the special optics they have.
Thank you very much, Christian. Let's go back to Markus. I want to talk about OCT. I'm a huge fan of optical coherence tomography for the medical sector. We had certain meetings only about OCT for medical. That market is growing. When it comes to the OCT for real-time inspection, what are the main challenges today? Are we prepared already to do fast real-time monitoring of large surfaces?
The main challenge is to get the users to be aware of the topic that we are talking about, a sensor system which needs to be adjusted. So the measuring position is very, very important. We are talking about a spot diameter of about 50 microns and smaller. And this has to be adjusted. So it's different to many sensor technologies which we have seen in the past. So OCT has to be adjusted, but if it's accurately adjusted, it's breathtaking information and measurement results you can get out of the any kind of photonic process.
In the past, I have introduced you to many companies for the metrology sector. Many companies that were looking for developing different optics to integrate them in the laser heads of Precitec. Thank you so much for all the follow-up you do with all the introductions. But I want to introduce you to potential customers now, because actually we have BMIT in the room. Martina Riccio, thank you very much for being with us today, Martina.
Hello everybody.
How are you?
Okay.
It is great to see you again. It was great presentation at the previous meeting from BMIT. We made a lot of introductions. What did you bring to this meeting? What kind of opportunities for cooperation can we have with BMIT?
I also have presentation from laser metal deposition.
We
technology.
do have a problem with your connection, Martina.
The connection.
Yes, now it's a bit better. Go ahead.
Can you hear me?
Yes.
I have some problem with the connection, sorry. I said that I like the Precitec presentation because I like the laser metal deposition by wire process. And I was wondering if you are considering to use also smaller wire in diameters in order to overcome the limits of geometry of this kind of technology.
Yes, I think this is addressed to me. Yes, actually, we are going two ways. So the one way is that we need to compete against the wire arc process. So there are many disadvantages on the wire arc process, but there's one advantage, which is kilograms per hour. This is the one way we go. So we have increased the capability of standing very high laser power with the processing head. We tried 2 millimeter or even higher wire diameter to be able to build kilograms per hour. But on the other hand side, we can easily go with smaller wires. There is a sister processing head which is developed by Fraunhofer ILT. Which is working with 0.1 or 0.2 millimeter wire. So everything is possible with that optical concept. And we do see what is from the sales point of view the best way for Precitec to go. It's still some people at Precitec who want to earn money. It's not always R&D, and not everybody is fascinated with innovation like I am or Jose is, but sometimes you have to earn some money.
Yes.
Actually, my question came just because when I did my master thesis, I did it in laser metal deposition by wire in off-axis condition and with micro wires. So I was wondering if now maybe the industry is ready for this kind of application. And yes, of course.
Martina, I want to highlight that in the previous meeting, it was clear that it was a huge room for cooperation because BMIT is one of the largest solution providers for 3D printing that we have in Europe. And you were looking for many R&D cooperations. Actually, that was your call, starting R&D cooperation. So I want to refresh this. We already introduced many companies to BMIT, but anybody who wants to start any R&D cooperation in 3D printing, from beam shaping, from real-time monitoring to detecting of small defects, Martina and many others are the entry point for BMIT. Martina, grazie mille. Thank you so much for being with us today.
Thank you.
I have another question in the room. This one is coming from the company Sprana. Rasgatis Ricardas has a question for Valeria. Rasgatis, what's on your mind?
Valeria, I wanted to ask you, do you have experience with urea grade of steel metal product parts? Our industry is, we provide process analytics analyzers for chemical industry, particularly for nitrogen sector, and the environment is aggressive. So we use urea stainless steel grade. So can you elaborate on this?
Yes, thank you very much for your question. I can tell you, concerning the material point of view, For example, stainless steel that you mentioned is one of the, say, main material that we use, and also is one of the, say, stable materials. So there are a lot of study about the mechanical properties, the functionality and so on of this material. There are also other materials in progress or under research. So in the future, I'm sure we will see other materials that can give us different benefits in the different application. For example, duplex or tungsten carbide or spatial materials. So my idea is to, when we started in our companies, to use a say, stable machine, stable printer, and well-consolidated material. So the idea is to start to make design, parts, test the functionality of the parts, and then try to install the parts in the fields. This is really important to give trust to the industry about additive manufacturing, because only when the part is installed in the systems and it works for maybe 1-2 years, so all the technician can believe that additive manufacturing is a good technology. So I think it's really important to create good confidence to the technology.
Valeria, you're a star. You are really a star. You're getting the gold star of the meeting today. It was so great to find you. Really, really great. Thank you so much for being with us. Grazie, danke, Markus. We go to the next presentation. We go to IPG. One of the key companies has grown in the recent years. Even 2020 was a good year for IPG. Michael Lee, tell us what we can do to make IPG a great company even greater. The floor is yours.
Thank you. Thank you, Jose. Let me start my presentation first. Give me a second.
It looks good. Yes. No, you have to switch the screen that you're sharing with us.
Yes. So this is right now?
No, no, it's perfect. It's perfect as your lasers. The floor is yours.
Okay, so let's go back to the first slide. So my name is Michael Lee. I'm working with the company IPG since about 8 years now, focusing on, let's say, market development and application development for micro machining applications in Europe. And be happy to talk to the EPIC network today and in many other cases, as I found it very productive. And taking that back to the 3D printing industry, I have seen the up and downs, let's say, in the past decade with that industry. And I guess it's a European success story, honestly, with all the technology on the continent. It's a European success story, and I want to be this successful in the future as well. And that's why I'm supporting to discuss about business cases, which I can link to our portfolio, and helping you as a technology leading company to get to the next level of costs, of throughput, and so on. This is the intention of that talk. Let me share the next slides. So basically, I have seen the list of attendees. Most of the attendees should know us. For them who don't know yet, let me introduce very quickly. We are a huge company in the laser industry. And to be honest, here behind many of the machines in powder bed metal printing or in wire metal printing, we are the light source behind. And you have seen it maybe on some presentations already in advance. That is the truth. So we have a huge proven, let's say, track record on the build hours, on the number in systems in the field, which helps us to make the systems better for the 3D printing industry. This is what I wanted to emphasize. As a technology leader and pioneer of the fiber laser technology, we are linked with the 3D printing industry since almost 2 decades. So we have been in the early stage when this industry, this metal printing industry, switched from inefficient CO2 lasers to the first fiber lasers at that time. And it is an amazing story on the continent, how this were taken from the institutes, from a few R&D systems to really widespread in the industry. And we all want to continue on that, I guess. So you see here some of our reference customers on the list down there. So EOS and SLM, for example, which have a long way with us already. To continue with that, let me share some of the insights on what we are working on and what we want to continue with you on discussion points. Recently, we introduced the world's most compact fiber laser sources, which are used in the 3D printing industry right now. They are not limited only to 1 kilowatt, it's going higher. These are, let's say, the most compact systems on the market, which save some costs in the machine, of course, and some space. More widespreading ideas, I mean, we have seen the race between the integrators for putting more and more laser power on the machines. And I guess this race is headed up by SLM currently. You see an example on the right side. And as I understood, Valeria, you're one of the earliest users of such a nice tool with so much laser power on the machine. So good luck for that and getting processes and many parts done with that amazing tool. Of course, this is only one part of the race. Let's say putting more lasers on one tool and stitching the scan fields. On the other side, we have heard already about the mode beam propagation switchability. So we call it adjustable mode beam laser, AMB laser, which we can produce up to 25 kilowatt. And this combination of a single mode and multi-mode beam propagation can be switched, as we already heard, in milliseconds on the fly. So we are able to support you not always up to 25 kilowatt in the beginning, but let's start seeing how this enrolls into your processes with many kilowatts as possible, that you can get the cost down. And we have seen also for other materials that we need to adapt the wavelengths too. And in our really broad portfolio from the fiber laser sources, we also find suitable sources for high reflective materials. For example, I guess in the past years, that has been a huge topic for all of us, finding their suitable single mode green lasers for that. We're also having them in the portfolio, but also little, let's say, look over the to the polymer 3D printing machines, that different kind of materials can be directly addressed with different kind of laser sources, different wavelengths where they have different absorption behavior. And this is all within our portfolio. And we would be happy to discuss that further on. That already sums up to my presentation. I go to the classical epic question. But before that, let me sum up what I wanted to present. I mean, we are in many of the integrators. We're helping out them to increase costs, decrease costs and increase the throughput. And we would be happy to continue with a huge portfolio of different solutions from one supplier. What can we do for the EPIC network? I mean, with all the experience we have in the field, our lasers made progress since 2 decades, that we are a reliable source provider, plus have a proven world record on building hours, which is beneficial for the end users. And so what can you do for us? We would like to take your business cases, discuss about them, about your ideas to get rate, reliability, and repeatability on the next level, that we can succeed with that 3D printing story on the European continent further on. And so that's why we're looking for partners which can take more designs or new designs which absorb more power and even reduce the footprint per watt and the cost per watt further on. Thanks for listening.
Thanks a lot. I hope you hear me now. Yes, Jose is happy. So sorry before I was dropping down. So thanks a lot for your contribution, Michael, and it's great to discuss always with you also on a general level. So I have first a question that is a bit more general in a way that he was saying. So you are dealing with different materials. So we saw the different also wavelength that you are trying to approach. And I guess that for AMCM, there is also a question. So that's maybe he can ask this in this topic, right?
Yeah.
Bernard, thank you.
Okay, thank you. I mean, first I have the impression that if you have faster scanners and more laser power and more lasers, the whole process runs faster. That's just part of the story. If you add more horsepower to a car, it doesn't mean that you can drive faster on the road. So you have to consider heat impact into the powder and all that things. So we're working on that. Beam shaping is an issue, but there's many more, gas flow and than just laser powers. Just to correct that a little bit from the previous discussion. My question to IPG is following. Your current green lasers are pulsed, and what we need is CW, especially for copper materials. Is there any progress with the current model?
Thanks for raising this question. So actually the lasers are QCW, having repetition rates of 180 megahertz. And to my understanding, the material integrates over that already.
We have integrated one of your QCW green, and the results were not as good as CW. That was first part of my question. So it's still a QCW green laser, right? Yes. The other question is, I've heard, is that true that you're gonna stop the current models from 202 kilowatt lasers and replace them by new models very soon, which reduces, with that respect, the frequency maximum of 50 to 10 kilohertz? Is that correct?
That's not correct, and we have discussed that on the side pass yesterday. So I see the same background as in the discussions yesterday.
Could be that.
Different colleagues.
Could be. I just heard that.
No, we just in discussion on the side pass. Let's do.
Okay, fine from here.
Very good, very good. Otherwise, Bernard, do you have other, I mean, we heard that, okay, the laser side, you addressed already all the challenges you have. Do you want to mention a part of the beam shaping we heard already, and then maybe we will ask Tifane about her opinion on this from Trilabs?
Well, generally, I mean, we understand that beam shaping can have a very good impact on productivity of the systems. Yeah, but there's a lot under development, and there's a lot of possible solutions. Could be different lasers, but could be other items. So, but it has an impact, yes, first of all. But also, for example, in multi-laser systems, we already had to reduce speeds because of the heat impact into the powder. The powder is a good isolator. So we have to consider gas flow, that one laser beam on multi-laser systems doesn't work in the gas, in the flow of the other one, which reduces the quality reduction and so on. So there's a lot more things which need to be considered. And I got the impression in the beginning that if it comes to powder bed systems, that it was a bit more, if you do the beam shaping right, if you add more lasers and higher laser power, make the whole thing cheaper, then we have higher productivity. Higher productivity is very important. And of course it is the target, I guess, to any system manufacturer, but there needs to be, a lot more things need to be considered, and not all of it can be solved easy.
Yeah, but that's very interesting for us to know, because we really hear more and more that is issues with the power in the optics and in all the part of the systems. Not only 3D printing is really important, but we have here in the room Sabrina from Asfericon. Maybe she can tell us a bit what is her opinion. Is Asfericon dealing with the high power? You think is this something that you can address?
Yes, thank you, Francesca. Of course, this could be something where we could help, but also optics are always limited in terms of high power. There is a special border where the material isn't working anymore. But of course, yes, we work on high power laser optics that can help you and that can suit into that process. And also we do have options for beam shaping solutions that can help to improve your throughput and to increase your efficiency. So yeah, let's get in contact. If the optics themselves don't work, we might have to switch for a mirror solution, but we can also help with that. So I'm happy to jump in.
Sorry, maybe my wording was not understood correct. It's not about power, it's about powder. Heat impact into the powder, that is a limiting factor. Hasn't got to do anything with power or optics or whatever. We have
we can't help with the powder. We don't do anything on the powder, but if you need to get the power of the laser better to the powder, then let me know.
I apologize,
yeah,
I drove the wrong one. But
All
then
good.
going back to the beam shaping, that is an issue. So Tiffaine wants to comment on this.
Yes, it was same again about the power. So if you have some issue about the power, we have developed solution with reflective optics where we can cool it down backside, and so we can have power up to 16 kilowatt, and we have very few focus shift. So we have a reduced focus shift in comparison to let's say more usual processes. So that's something we could work on. And about the power on the powder and the heat and things like that, we would be very interested to find end users or application cases where we could try some shapes on the powder to see how it can increase the heat affected area and to increase that.
Very good. Thanks a lot, Tiffaine. And then going back to my first question, and then we interrupted. So back to Michael. If you remember at the beginning, I was asking also to Brede if you see in general with your experience in subtractive and additive manufacturing, do you see as well a possible collaboration among the two technologies? Because we heard this last time by Sintef, so maybe they can comment after this. But what is your feeling about the strength of both technologies, and how is the future or the perspective in your opinion?
Now we see that the integrators have already subtractive and additive machines as a combination on the market since quite a while. So they do this rough processing by subtractive and finally build up some fine structures. So this combination is already available. Yeah, but taking one single beam to the powder bed, I fully agree with Bernhard that it does not win the race. So we have to think about clever technologies to split the power and not to, let's say, heat overload the powder and so on. And here we look for clever ideas to come up with 10 kilowatt, multiple tens of kilowatt sources, which can be effectively put into the material that the building rates going up to many kilograms per hour.
So Brede was maybe wanted to comment on this before, because you started to speak at the same time.
Yes. My point is that for most of the components that we will need in the energy industry, it could be small, complex, large, bulky materials or bulky components. Usually we need both. We need additive manufacturing, and most of the time we need post-processing with traditional machining to make sure the flanges and other contact points will not see any leakages, or you can hold the pressure in. So in that sense, we need both. And we also see that in some cases it's more cost efficient to use additive manufacturing. And in other cases, it's more efficient to use more traditional, like CNC machining. So our ideal would be to have a factory with all the available technologies needed to produce fully functional mechanical parts.
A factory with all the technologies is a huge opportunity for the members. Brede, listen to this. Listen to this, because I have something big to show right now. This is a company, one of the most innovative companies in EPIC, Hummink. They gave us goosebumps the first time they presented the 3D printing technology. Pascal, thank you very much for being with us. Give us the wow factor now.
Hi, everyone. Thank you, Jose and Francesca, for hosting this. I'm going to share my screen, if you don't mind.
I don't know if they're looking for investors, but I would invest.
I don't know if you're able to see my screen right now.
Crystal clear.
Yes, so we're Hummink. We do additive manufacturing at the nanoscale. Basically, we use a patented technology that combines a nanometric pen that you can see here with an oscillating macro resonator, which is this big tuning fork, to perform capillary deposition of any liquid material on any type of surface. And basically, the system's movement, which is AFM inspired, adapts to the specificities coming from either ink or the substrate to manage this deposition. So I wanted to join this 3D printing meeting since we're able to, as I said, print different types of liquid, and we can deposit colloidal suspensions of metal, and we've been able to deposit silver ink pillars like this. Here we have a 15:1 aspect ratio, and you can see that we can design objects at a very microscopic scale, and we're able to design a forest of silver ink pillars like this.
Any liquid into any structure. This is not metal printing. It is not, I agree on that, but this is one of the most innovative things I have seen in the 3D printing ecosystem. Any liquid can be 3D printed onto any substrate, and they have the whole process and they want to make their own machines. Francesca from Ferrari, let's discuss this offline, but this is one of the most innovative companies that we have in EPIC. Pascal, don't answer the question about the investment. I know the answer and I want to put some money on this. This is really, truly great. Thank you so much. And I want to go now to the next presentation, and I want to go now to a company that has made a big difference in the field of shortwave infrared, squid sensors, new imaging technologies. I didn't make a mistake this time. New imaging technologies. Francois, Coursaget, thank you very much for being with us today. NIT, the floor is yours.
Yes, hello everybody. I'll just share my screen a little bit. 1 second. Up, here we go.
Hummink can complete any liquid into any substrate. This is crazy. Sorry. Go ahead,
fine.
Francois. Go ahead.
Well, thank you, Jose. Last time I actually spoke at the at an EPIC conference. It was in San Francisco a year ago, so it's very interesting to. It was my last face-to-face conference. So
let's try to go screen mode, presentation mode. Let's go there and make it like big for everyone.
Yeah.
There you go.
Here we go. There we go. Okay, do you hear me?
Loud and clear.
Okay, so I'm Francois Coursaget, General Manager of NIT. So who we are, what we do, and why we're here, actually, that's a big question. So we develop SWIR in-gas sensors and cameras that go along with those sensors. And everything is done internally. So we have the 100% internal know-how from the readout design of the sensor, design of the material, in-house hybridization. We do all the electronics, FPGA, around the camera. And those cameras go for, well, are implemented in industry, machine vision, scientific applications, defense applications, space applications, arts, whatsoever. And for 3D metal printing, why is SWIR interesting? So if you look at the graph, SWIR, shortwave infrared, is in between the visible and near infrared and the thermal midwave and long wave infrared. So the long wave infrared or more is essentially thermal information. The visible and near infrared is essentially reflective light. And shortwave infrared is interesting because it's actually in between. So it's in between. So you have both the visible information on what you're observing, but you also have thermal information for temperatures that go above 300 degrees. So typically for 3D metal printing, you will have temperatures going from 300 degrees to more than 600 degrees or even higher, depending on the material. And we talked earlier about the dimensional controls of the process, but another control, which is monitoring, which is important, is the cool down temperature, because the cool down of the material itself will be able to have a good link with the eventual cracks that could appear in the material. And those cracks, if you wait till the end of the process to check them, well, it's going to be very expensive. Precitec and Markus mentioned 110 hours to make some huge tubes, and of course Brede and Valeria with their tubes can't wait till the end of the parts to check that there are no cracks in the material. And this cooling curve helps to find out that there are no cracks. Now, why an IT sensor? Well, our sensors have a unique and patented pixel design, where we have this 120 dB dynamic range within one single frame and within one single exposure time. And then that means that we can actually explore this huge dynamic range from the visible reflections all the way to this thermal information up to almost 1,500 degrees with a single capture. So that means that you could really control your process and your cooling down process of the 3D printing. So very quickly, in terms of products, so we started in 2016 with the first generation with this HDR logarithmic pixel in 2016, second generation in 2018, going down in pixel size and combining high dynamic range and high sensitivity, going down in 2020 to a more industrial 7.5 micron linear array, and third generation megapixel 10 micron going to be released this year. And what's interesting is that we participated in the contest organized by the French BPI, which is the Public Investment Bank. And we won a contest to develop a dedicated sensor and camera, which will really be dedicated for this application of 3D metal printing. And we're expecting to have our first dedicated cameras available through the summer. And so we are working with two partners today on actually making this link between the thermal cooling process and avoiding those cracks or any defects that you could have while metal 3D printing process. I have a video. I'm not sure the video will run. So if it does run, well, let's hope so. And in any case, you can see the video on our YouTube channel, which is New Imaging Technology and IT here. And you can see and check that video online. In any case, let me just speed up the video to the interesting part. So this is done with the Moderators Institutes. So what's interesting here is on the left, you will have the visible CMOS image. And here the same image with the shortwave infrared. And so with the shortwave infrared, you can see that temperature decrease along the lines. And you could really measure this thermal information and see how the cooling curve is and does behave.
I think we are not hearing the sound. So tell us what we are seeing, which is, by the way, beautiful.
So what we're seeing here is, once again, what we're seeing on the left, it's the visible CMOS imaging. And on the right, there's shortwave infrared imaging, where you can see that you can have this information on the cooled down surface of the material. So that's the main difference you will have with the CMOS imaging sensor, is that with the shortwave infrared, you have thermal information. And that thermal will give you, let me just try to turn the sound off on the video.
Oh, it's okay. We cannot hear it anyway, so it's fine.
Okay. Okay. So, you're not, so there's no issue. I am bothered by the. I don't know how to take that off.
It's okay. It's okay. Just tell us what we're supposed to be seeing.
So in any case, what I was saying is, oh, here we go. Okay. So here you have the video. Yeah, I'm just speed up. I just can't. Oh, there, got it. Okay. Here. This is the welding on titanium, where you can see here the interest of having this logarithmic mode, where you have a very high reflectance and high temperature, and you can really control this curve and have this information on the cooling of the material itself. So we are working with the CEA, which is the French Nuclear Energy Research Center, and to be able to do this this link between this thermal cooling and the quality of the print itself. And so we will be able to present something together within probably the end of this year.
Very good, Francois. So that's the epic questions. Very good.
So yes, so that's the next question. So what can you do for us? So we are looking for partners. So we are a small SME. We're 20 people developing this technology, and of course we work with partners. And typically we would be looking for partners that would work on the packaging side, because that's one of the critical issues when we're making cost-effective solutions with SQR sensors. The other issue is the optics itself, because it's nice to have a high dynamic range sensor, but if you don't have the high dynamic range SWIR optics that go along with it, then that is also tricky in order to have that to capture the whole information, the useful information. And then, as we are not software oriented, but we are really developing the camera, it's always interesting to work with partners that have this software knowledge in terms of development of thermography type applications. And of course, we're looking for trial tests, and we need to accumulate as many sample tests in 3D metal printing to be able to aggregate as much information as we can to better understand how all this works. And what can we do for you? Well, what we can do for you is offer our products as we design products and how these products could answer your different needs.
Thanks a lot, Francois. So I guess in the chat we had already some comments. So maybe already interested people in implementing your device. So let's ask Valeria. So she was asking, right? Can you take the floor, Valeria?
Yes, hello. Thank you, Francois. Very interesting. My question is how to install your sensors in the printer, in the existing printing. Did you already think about practical way of install the sensors, or is it something that is under research?
No, it has been done because the Institute Moderators has already been handling those and tried different ways of implementing it. Actually, the size of the camera isn't that big. It's actually quite small, so it could be implemented like a head at the head. And since we are not, we don't have any issues with the dynamic range, we could be very close or very far away, and we won't have this effect of the blooming. So it would have to be worked around with the, of course, with the manufacturer of this complete solution. But these are part of the topics that are being worked today with this Institute Moderators.
Okay, thank you.
So in the room, we have also other experts that maybe we didn't hear yet talking about 3D metal printing. And one of them is Rico Peters from Rostock, from SLV Rostock. Maybe you can comment a bit on what SLV is doing and your experience also with the process monitoring.
Yeah, thanks a lot for this question and the introduction. So we are working in the field of 3D metal printing and powder bed solutions, as well as in wire arc additive manufacturing, laser cladding with powders, and also with wire sources, as we heard also today. And since the end of last year, we are also producing and developing our own powder sources for our own powder bed fusion systems and the laser cladding process. So what we can offer also since the last year is to produce and to develop novel alloys. And I can also pronounce and underline the things Bernard also says, that the laser power is not the only point, and especially if you have these processes with kilometers and thousands of kilometers of weld seams. In fact, the temperature is it's the biggest issue. So in the whole process, like in wire arc additive manufacturing, even if you have very high productivity, at the end, the whole process has to be stopped after several hours or several minutes to get a recooling of the whole product. And that is one big issue where we are working on at the moment, and where we are also doing education and training for the operators of the different systems, because that is the most sophisticated point at the whole process. So one point is that you have to have very sophisticated systems for the calculating the temperatures and so on. And at the end, of course, we have to have some persons who are able to work with this very complex systems at the end. And also in this point in education and the powder development, we can also give some offers and some points to work on. Thanks.
Thanks a lot, Rigo. And now, because we have here two European initiatives showing how people can really work together in Europe, I would like to give them the floor. So I will start with AIMEN, introducing Pasek in our open call. So if you can unmute yourself, there you go, Ambroise.
Thank you, Francesca, for the introduction. So yes, at AIMEN we are coordinating a European initiative called Coursaget in order to build a network of digital innovation hubs and competence center to help the European industry to implement new technologies focused on laser beam advanced and additive manufacturing. The project just started a few months ago, and this week we just launched the first open call, which aims to found 10 experiments to perform the development, testing and validating of technical and economic viability of new technologies in this field of laser beam and advanced additive manufacturing, So a new technology developed by SME and to be implemented in an industrial environment for manufacturing SME in Europe. So the call ended the 22th of April. In this link, you can find all this information. And from today's speakers, we already listened to a lot of very interesting applications that could be interesting for this kind of call. Thank you very much.
Thanks a lot. Thanks a lot. So this is, don't miss the date. This is the first call. There will be others coming, but let's concentrate on the first one. And we are really looking forward to also welcome SMEs that have no idea of what, how can they work with the laser. So they don't have they know, but they didn't have the opportunity. So this is a really nice tool that is given to us also with the support of the Commission. And as we heard already, it's really important that in Europe we are all connected.
This is the first time, Francesca, the first time that we are actually offering heavily subsidized, very heavily subsidized 3D printing and advanced manufacturing prototype. This is a huge opportunity for companies like Additive Industry. Henry is smiling because he's thinking business now. If they are looking for a new process, there's a heavily subsidized way for you to work with Syntef today. This is a huge opportunity. I'm very excited. I'm not going to miss the lunch for this, Francesca. Sorry, I can't wait being excited. Sorry.
Yeah, because also here we have other opportunities that we would like to discuss as well. So we have also Roman from Amires, and he has also another offer to propose us, right, Roman?
That's right. Thanks for giving me the floor, Francesca. Hope I will incite the excitement that is usually present at these meetings. So the thing I have over here is a bit similar to what was presented a while ago, but yet the scope is different. So I think that we're not, let's say, double dipping here in any way. So hopefully you can see the slide in full screen mode. So basically what we have here is a project again funded by the European Commission in Horizon 2020 program called Manuela. And we also have a cooperation opportunity for you in terms of an open call, which is currently open. So basically, I'll try to be brief with what it's all about. What we can offer is a one-stop shop for basically the full development cycle of metal AM. So we are including also simulation and modeling activities, of course, the manufacturing itself, but online process control during the manufacturing, also some machine learning algorithms that feed into real or give real-time feedback for the manufacturing process. Of course, also post-processing, so post-treatment characterization services, and all, let's say, in line with qualification protocols, so that it's all very easily adoptable by the market. We use powder bed fusion technology with laser beam and electron beam. So we have different machines for that. We're also working with a range of materials, so titanium alloys, also aluminum alloys, stainless steels. That there's quite a big assortment of those. So you can of course find more information on the website. So I think I don't need to go into detail on the benefits, because these are, let's say, general for additive manufacturing in general, and you are all very much aware of that. So let me just say that this is an opportunity that can enable you to, let's say, try out how this process could look like for your product development. This will be 50% co-financed by the project itself, so by the European Commission. It is open to any kind of company, regardless of its size or the industrial sector. And basically, the applications can cover any or all of the phases of the process that I was describing. So if it's just about, let's say, some material assessment and characterization, or about the post-processing, whatever is your specific need, you can apply with a very simple application, if that would be of interest to you. So that's all I wanted to share. Of course, if there are any questions, I'm happy to answer them. Thank you.
Thanks a lot, Roman. Thanks a lot. So as we see, the Commission, we heard the last meeting that everybody's wishing, the big companies, we heard from automotive, from the energy sector, that they are wishing for really the Europe working together. So the Commission knows about it, and so it's good that also this contribution is given by them to SMEs and companies in Europe. So that's really nice to know. But now let's go back to the hardware. So we have a solution finder in the room, so many, so of course it's not only him, but he, Hans today from Demcom, would like to give us a couple of examples of what they can do for more, going back to the hardware, so not only the monitoring, but also the system integration and engineering expertise there for 3D printing of metal, right, Hans?
Yes, that's correct. Thank you, Francesca. I will share my screen. Right, is it visible?
All good. There you
Okay,
go.
thanks. Right, thank you for the opportunity to present DEMCON in this consortium. For me, it's the first time, so please excuse me if I, well, don't understand the full epic questionnaire last lines for the presentation. I tried to write something down, but at least I try to give the best of my opportunities to demonstrate what DEMCON can do in the field of 3D printing. Let's first start with a little description about what DEMCON as a company is. We are currently a rather fast-growing company that is a high-end technology supplier for systems and products. So we are based in the Netherlands. We have 4 offices in the Netherlands. I'm currently in the main office in the eastern part, close to the German border. And quite recently, we've also opened a new office in Singapore, so we are now also going worldwide, and we also have an office quite close over the border in Germany. So as I said, we are quite a fast-growing company, and what is most interesting from our perspective is to know that the development within DEMCON is that we can provide customers with a full solution from prototype all the way to industrialization and even series production. So we are really a technology supplier. We take a problem from our customer and we take it all the way to the market, so to say. So it's a full package. Well, in the top right corner, you can see a few keynotes about the background of DEMCON. So we are founded in 1993. We have currently over 800 employees. We are an independent company, so we are not stock registered. And what is also important to know is that we are currently working in multiple markets. You can also look it up on our website, obviously, but the main markets are high-tech and the semicon. Also, the medical and life sciences is an important market for us. And more related to this EPIC meeting is also the optomechatronics and the industrial and robotics target. And obviously also what we do is the thermal and cryogenics, which is more in the cooling and thermal management systems. Let's see if I still have control. Yeah. So what is important to know about DEMCON is that we are able to provide tailor-made systems from all the way from the definition of a problem all the way to production. We do that via many different capabilities or competences within DEMCON. So we are consisting of a large team, so more than 800 employees with a rather highly educated and skilled background. So you can see the numbers in the lower right corner. This also means that we can provide a really high-end solution to all of your problems. So in that case, this EPIC meeting for us, it's more like seeing what the market is looking for in technology questions and also solutions. That's where DEMCON can provide a lot of assistance and also development and technology solutions. I will not run all the items down, but the most important are obviously the mechanical, optics and vision, the analysis, which is the simulation department within DEMCON. We obviously have quality and engineering. We have the manufacturing. We do a lot of software, so many of the software inside the system is coded by ourselves within the various software languages. We have an electrical department which is capable of also doing our own PCB layouts for well, all kinds of high-tech and also the miniaturization steps within robotics projects. And where my field is in the mechatronics. Sorry, I was a bit distracted there. My field is within the mechatronics, so where the total combination from all the different kinds of fields are now integrated within a complete system that is that includes all these different competences. Let's see. So we have experience with some 3D printing projects. So we all do it all for external customers. I found two that we are able to share. It might also be interesting to know that we do a few more projects, so it could be possible to discuss that after this presentation, more like a private discussion, but these are two that I can provide during this meeting. The first of which is a true 3D metal printing system that we developed for the University of Nottingham in collaboration with a well, rather large, well-known standard 2D printing provider. This provider also delivered the printing heads for the metal jet printer. So they developed a method or technique to make well, high temperature metal droplets. And we were asked as Demcon to provide a system that is able to incorporate this head and make a full 3D printer out of it. Just for your clarification, you can see a few images below, and this slight small castle-like image, it's a few centimeters by a few centimeters. You can obviously see a close-up of the various droplets. So it's more or less like a 2.5 to 3D small-scale inkjet-based jet metal printer. Demcon developed the machine all the way from the print chamber climate control up to the motion platform and also the vision, how to say, the vision systems to also quality control the droplet formation. And it also developed the software architecture to make sure that the printing process is working nicely, obviously. Then the second example that I am able to provide during this presentation is not so much a metal printer, but a very interesting printer. It's a polymer printer, which is able to provide 3D prints with PEEK. So I'm not sure if everybody is familiar with the polymer terms, but PEEK is a very high performance plastic. It's up in the top peak of the pyramid of polymers. It's relatively hard to print, but it's a very interesting material from the perspective of the chemistry and the strength. And we were asked by our customer Bond 3D Printing, so the company owning this printer is Bond. They contacted us a few years ago, and they envisioned a way to perform 3D printing with this material, so with PEEK. And during the course of a few years, Demcon has developed a complete 3D printing system for our customer Bond to make sure that they are now operating with multiple of these large 3D industrial 3D printers, able to manufacture high quality PEEK material parts. So they are really unique in the industry at this moment. So this is a clear example in how Demcon is able to provide a question from a customer, like we have an idea how to make this material printable and how to be able to make sure that the strength of the material is really incorporated in the part. Can you build a machine for it that can make it industrial printable? And that's what Demcon eventually did. They made a complete 3D printing platform all the way from test setups to prototypes to now the final production series. So that's in a nutshell what Demcon is can do for customers. Obviously,
answer.
yeah.
You need the heavy questions. Yeah.
I wrote them down. Yes. What can you do for us, and what can we do for you? Well,
exactly.
What can you do for us? Well, at least for me, I stepped into this meeting to get a first glance of what is out there in the industry of metal 3D printing. Obviously, it's more focused on the photonics, which is a bit of my background, but not my current role within Demcon. But obviously, what you can do for us, it's if there are challenges in the community, in the industry, contact us to see if there are any opportunities in which we, with as Demcon, with our background in photonics, in mechanics, in putting ideas into market all the way through the prototyping surfaces, etc. Contact us and we can do development for you. So we as Demcon, we provide the technology, you provide us with the idea, how young the idea is, at least. Yeah.
Very good. Yeah, that's a good point. And also considering that you show something that is also not only metal printing, so it's also more other polymer printing. The good point is that for the monitoring people, so dealing with the process monitoring, this is also anyway attractive. And so given the point that we have also another camera maker in the room, maybe it's now the time to give the word to Herman from New Infrared Technologies, looking more at the longer wavelength, and let's see what is their solution, right? Right, Herman?
Right. Good afternoon, Francesca. Good afternoon to the community, additive manufacturing community. I would like to share my screen. Can you see here? Can you see?
If you make it a bit larger, yes, perfect.
Okay. Okay, just to say that NIT, which is new infrared technology, is not new imaging technology, which is we are completely different companies, but with the same acronyms, and we make cameras, but the cameras that we make are medium wave infrared cameras. It means that they are sensitive from 1 to 5 microns. It has a big difference because we can obtain a higher thermal contrast. The other big important characteristic of our camera is they are really fast. I mean, we can capture in the snapshot mode like 2,000, 3,000 frames per second, which is very important for this type of process that it is necessary to monitor and control the heat produced during the additive manufacturing. That we would like to present here in this community today is the system Clamir, which is one of the more recognized systems for monitoring and controlling in real time additive manufacturing process, metal additive manufacturing process. It is installed in coaxial mode, and it is able to control the power of the laser in real time. It means that it based on the some feature related with the melt pool, like a size and also other type of feature like signal, etc. We are able to control the power of the laser. As you are mentioned during the presentation, the additive manufacturing is getting more and more complex. You are speaking about beam shaping, we are speaking about to change powder, etc. And control and monitoring will become a key part of the process if you want to be reliable. I would like to, I don't want to extend a little bit more. You can see here in the slide 2 examples. One of them is in Trump. You can see here how our system works in controlling the power of the laser and also in laser line, which is you can see here the big advantage of using monitoring, real-time monitoring and control system based on infrared imaging, high speed infrared imaging. Thank you.
Thank you very much for this. I mean, actually, the M-Weir cameras of NIT have been attracting a lot of interest from this industry. We are developing, as many of you know, the Mid-Infrared Alliance with all the companies developing mid-infrared technologies, and NIT in the M-Weir sector is actually one of the driving forces here. So thank you very much for this. It is great what you're doing in the 3D printing, and it is great what everybody is doing in the 3D printing world. I want to finish the meeting with two people. I want to first give the word to my two gold stars of the show. First, Harry from Additive Industries. Harry, it was a great meeting with lots of different room for cooperation. I think we actually, Harry, yes, you are. Give me just one final remark, one final thought to send these people away.
Okay. Well, once again, it was a very exciting meeting, and all the knowledge coming here together. And I think approaching the challenges of additive manufacturing with this broad scope, and I see a lot of connections coming up, a lot of opportunities. But in general, I think with this drive of innovation and all these knowledge together, we will definitely move forward this technology into a let's say embedded in and maybe taking over a conventional technology. So absolutely, specifically. In
a meeting with Equinor, with Ferrari, with AIDRO, with ACMC, so many room for cooperation. Valeria, you are going to be the person to give the final word. Well, I will be, but you before me.
Thank you. For me, it was the first experience, and I'm really amazed by the great community that you are creating. So thank you very much, Jose, Francesca, and all EPIC team.
But you know what we do great? Do you know what we do great? Is when we hear from people like you and we match it with solutions. That's what I did. I was writing a lot during these 2 hours. That's what we did today here. We heard from Equinor, from Ferrari, and from AIDRO about potential rooms for cooperation. First of all, they were talking to us about post-processing, including laser-based structuring to reduce the friction. There, we have scouted a real opportunity for collaboration with Siemens that was presenting in the previous meeting, multi-beam, ultra-fast laser for surface structuring. But also we have also the opportunity to actually collaborate in real-time inspection. And their Precitec, new infrared technologies and new imaging technologies have shown OCT, S-Weir, and M-Weir cameras to collaborate. We also heard a little bit about the wide range of materials needed. And their Precitec, that was spectacular. Markus said to us about direct energy deposition that they are actually presenting as an alternative to additive manufacturing. That was for me the highlight presentation of the show. And also we had BIMI telling to us that we want to have more R&D cooperation. And that was Francesca worked really hard on bringing today Manuela and Pozo that are offering prototyping services heavily, very heavily subsidized by taxpayers' money. So use it wisely. And also we have from AMCM. Thank you so much for being here. 3D printing machine optimization. And there is huge room for cooperation because we heard from L-Lights AFX, ultra fast beam shaping, keeping the average power and in milliseconds going from one beam shape to another. Huge room for cooperation. The conclusion, we keep working together. I just want to say that, you know, it looks like the meeting is over, that we can relax now. No, that's wrong. From Nordvik by the Sea, I can tell you that the meeting starts now. The meeting starts with the follow-up. All of you have presented room for cooperation, but now is when you have to exchange emails and get in touch with each other, have conference calls, and make innovation happen. Nobody's doing anything great in the world by doing it alone, and that's what I believe in the work that we do here. On behalf of a fantastic team, EPIC is a fantastic team of people who like each other and love working together with photonic integrated circuits experts, medical experts, laser experts like the great Francesca Moglia, and medical earth experts, a great innovation manager, great marketing people, great CEOs, great, well, a weird CTO like me, but other great people that want to help the industry, and that's why we never sleep. We don't sleep because we care too much about the sustainability of the photonics industry. Here is the calendar of upcoming online technology meetings. Look at the LiDAR 2.1. That's what is going to be epic. Until the next time, wash your hands, wear a mask, take care of each other, because I can't wait to give you a hug. Bye-bye.